Hi, my name is Victor, and this is my concept map. I decided to start with the atom because it's the smallest, one of the smallest things, yet it's also made of three other things. Those things are proton, neutron, and electron. Protons are related to Dalton because one Dalton is equal to the mass of one proton. An atomic number is the amount of protons in the nucleus of an atom. And that's where you have neutrons, which are also found in the nucleus. Both proton and neutron are found in the nucleus of an atom, where the average of the amount of protons and nucleus in an atom make up the atomic weight. Now we go down to the electrons, which are found in the electron cells around the nucleus. And you have the outermost shells of those electron shells. Those electrons are called valence electrons. Now these valence electrons are very reactive, which give rise to the opportunity of bonds. And you have nonpolar covalent bonds, which is a bonding between two elements that are very close in electronegativity, which is how attractive they are to electrons. So in here, because it's covalent, the sharing of atoms is mutual. Is the same amount of sharing going on. And you also have polar covalent bonds, which is between molecules that are very different in electronegativity. Ionic bonds, which is where electrons aren't shared. They aren't shared evenly, unlike covalent bonds. And you also have double and triple bond, where two pairs of electrons are shared, and triple bond where three pairs of electrons are shared. Now, going back to electrons, in order to have a bond, you need to have an electron acceptor and an electron donor. Usually, electron donors can be a way to describe an electron donor can be a base, which a base is on the pH scale is high on the close to above 7, and it can also be described as an anion because it has a partial or negative charge on the either molecule or atom. You also have electron acceptors, which are acids. Can be described as an acid, which has a partial positive or positive charge to them. Now, a salt is a conjugate base of an acid from a reaction between an acid and a base, where the hydrogen donator is replaced with a metal like sodium. Now there's different types of atoms, which are called elements. Now when elements come together, they form what's called a molecule. Molecules have a molecular weight, which is the sum of all of the elements in that molecule's atomic weight. And then you have Avogadro's number, which can be used together with molecular weight to find the mole of the desired molecule or element. And then molarity, which describes the concentration in a solution. Then you have a gram, which can also be used with Avogadro's number and molecular weight. You can use these two to find how many grams of the desired molecule. For example, of water, you have H, which is 1, you have 2 of those, and then you have O, which is 16, making it 18. Now that's a molecular weight, which is constantly equal to 18 grams. 1 mole of it is equal to 18 grams of water. And then the gram, liter and meter are also base SI units for measurement. Liter is for volume, meter is for length. Now on the other side of the elements, you have life. And then you have secondary elements for life, which are sulfur, which is a very active yellow metal, sodium, which is mainly found in ionic molecules like salts, and they produce either basic or acidic solutions. You have phosphorus, which is found in molecules like ATP and nucleotides. Potassium, which is a very reactive silvery alkaline metal. It's also very soft in room temperature. And calcium, which is found and is stored in bones for animals or another life. You have the critical elements of life, which is hydrogen, which is the simplest element that there is, the lightest. Nitrogen, which is found in amino acids and nucleic acids, is a key component of them. Carbon, which is the backbone of and building block of life, and oxygen, which is found in many polar covalent bonds because of its electronegativity. Its high electronegativity would make that molecule a polar covalent bond unless it's a higher electronegative or equal amount of oxygens. Now, when there's a misproportion of carbon to oxygen, meaning there's too many carbons in a molecule, when compared to oxygen, it creates a hydrophobic molecule which repels water. Now, I forgot to mention here a very important molecule to biochemistry or chemistry or cellular biology, which is composed of a hydrogen ion and a hydronium ion. A hydrogen ion can be considered an acid, and a hydronium ion can be considered the basic base, I guess. And then the water molecules are bonded, have hydrogen bonds between their hydrogen and their oxygen, which cause a hydrogen networking bonding of water. Now, because it's between water only, it's called cohesion, which is which is hydrogen bonding between like molecules. And like hydrogen bonding, you also have adhesion, which is hydrogen bonding. I'm sorry. Between molecules that are not alike. Let me bring it a little closer so you can see the whole map and read it. All right, thank you.